Okay, let's start with a wild idea. What if everything you see around you, the entire universe, is actually made of just one single thing? There's a new theory on the block called the time force hypothesis, and it suggests exactly that. It says everything from the tiniest particle to the biggest galaxy is just a different kind of ripple in one single cosmic ocean. So today, we're going to dive into this radical idea and see what it could mean for reality itself. So here's our roadmap. First, we'll look at why physicists are even looking for a new theory. We'll explore the cracks in our current picture of reality. Then we'll get into the main event, the time force hypothesis, and its mind-bending idea of a single ingredient for the whole cosmos. After that, we'll see how this thing supposedly builds particles and forces out of pure geometry. And finally, the most important part, we'll check out the make or break predictions that could prove this whole thing right or completely wrong. All right, so you might be thinking, don't we already have a pretty good handle on physics? And you're right, our current model is unbelievably successful. But it's also hiding some deep, pretty awkward secrets. In this first part, we're going to shine a light on those cracks in the foundation of modern physics, and you'll see why some scientists are desperately searching for a new blueprint for the universe. I mean, you've got to hand it to quantum field theory. We call it QFT for short. This thing is an absolute monster. It's the most successful, most precise, most tested framework in the entire history of science. It's the engine that powers the standard model of particle physics, which is basically our best ever instruction manual for how the universe works on the smallest scales. But, and this is a big but, even champions have their weak spots. For all its glory, physicists have known for decades that QFT can't be the final story. It works, but it leaves us with these huge, nagging questions that just won't go away. It feels like we're only seeing a shadow of a much deeper, much more elegant reality. So here are the problems. Think of the standard model as the ultimate recipe for the universe. The catch is, it has this list of about 20 ingredients, these fundamental constants. And the recipe doesn't tell you why you need those specific amounts. We just have to go out, measure them, and plug them in. It can't explain why particles come in 3 different families or why their masses are all over the place. It's like having the world's most amazing cake recipe, but having no clue why you need exactly 2.5 cups of flour or why 3 eggs work but 4 don't. It just works. And for a physicist, that's not good enough. Okay, so what if there's a simpler recipe? What if all those mysterious ingredients aren't fundamental at all? What if they're all just different expressions of one single underlying substance? This is the core idea behind the time force hypothesis. It's a bold new attempt to build the entire cosmos from the ground up with just a single, elegant blueprint. So picture the universe as this enormous, endless ocean. The time force hypothesis, or TFH, says that everything, you, me, this planet, the stars, everything is just a different kind of wave or whirlpool in this single, universal sea. They call this the universal field. It's the one and only ingredient in the cosmic recipe. Space-time, matter, forces, it's all just the universal field doing different things. And here's the beautiful part. This hypothesis isn't just saying, hey, let's accept the universe's rules. It's claiming it can derive those rules from the fabric of reality itself. So instead of that long list of 20-plus numbers we have to measure, TFH says we should be able to calculate them from the pure geometry of this universal field. It's about deriving the rules, not just measuring them and shrugging. And this is where it gets really cool. This isn't just some philosophical idea. It makes a concrete, testable prediction right out of the gate. The theory's math calculates that the simplest possible ripple, the most basic vibration in this universal field, should show up as a brand new particle with a very specific mass, 2.05 giga-electron volts. This isn't a guess. It's a number that falls right out of the theory's core geometry, with no fiddling required. But hold on. How can one single, boring, uniformed field create the incredible variety of particles we see? I mean, how do you get an electron and an up quark and a strange quark all from the same basic stuff? Well, let's get into the really clever part, how TFH proposes to build all the blocks of matter out of nothing but pure geometry. You see, the standard model is like a particle zoo. You've got your electrons over here, your quarks over there, your neutrinos, all these different fundamental creatures. The time force hypothesis says, no, there's just one substance. In this view, every single particle is just a different kind of stable whirlpool, a vortex, in that universal field. Each one is a unique persistent pattern, like a knot tied in the fabric of the cosmos. So, what makes one vortex an electron and another a quark? It's all about its geometry. How many twists are in the whirlpool? That tells you its electric charge. What direction is it pointing in? That determines its color charge for the strong force. And how is it vibrating? That sets its mass and which of the 3 generations of particles it belongs to. It's kind of like a guitar string. The same string can make different notes depending on how it vibrates. Now check this out. One of the weirdest mysteries in physics is why quarks have these bizarre fractional charges, like +2/3 or -1/3. TFH has this amazingly simple answer. In this model, charge just depends on the number of twists in the vortex. So an electron is a vortex with 3 twists, which we see as a charge of -1. But an up quark, that's a vortex with 2 twists, which we perceive as a charge of +2/3. It's a really elegant way to explain something deeply weird. Okay, so we've got particles built from these geometric whirlpools. Awesome. But how do they interact? How do they talk to each other? Let's look at how TFH builds the fundamental forces of nature, not as some extra ingredient, but as the natural way these geometric vortices behave and influence each other. The big idea here is that there are no separate forces. In this picture, forces are just what happens when these geometric whirlpools get near each other. They emerge from this intricate dance of geometry. The shape and vibration of one vortex naturally influences the shape and vibration of another. It's all interconnected. So this table is basically our translation guide. It's a Rosetta Stone, translating the language of the standard model we know and love into this new language of geometry. What we call electric charge, that's just the twist number. The strong nuclear force that holds atoms together, that's all about how these vortices can be oriented in space. The weak force, responsible for radioactive decay, that comes from their internal wobbles. It's a whole new way of looking at things. Okay, this all sounds really cool, right? A universe from one ingredient, particles from knots, forces from geometry. It's a beautiful story. But is it science? Well, a real scientific theory has to be testable. It has to make predictions that can be proven wrong. And TFH does not shy away from this. Let's see the make-or-break predictions that will decide this theory's fate. And this theory really puts its money where its mouth is. It doesn't just predict that 2.05 GeV particle we talked about, it also makes a wild claim about the Higgs boson. It predicts that there should be these tiny universal accelerations everywhere that we might be able to detect. And it takes a firm stance on a huge mystery in neutrino physics, saying they must be a certain type of particle. These aren't just little tweaks, these are sharp, clear predictions that are very different from the mainstream. But maybe the biggest, sharpest test of them all has to do with the famous Higgs boson. You see, the standard model is perfectly fine with the Higgs sometimes decaying into invisible particles that our detectors can't see, and a lot of other new theories actually require this to happen. But the time force hypothesis makes a prediction that is completely, radically different. Yeah, look at that number. The time force hypothesis predicts that the chance of a Higgs boson decaying invisibly into these new TFH particles is about 1 in 10 to the power of 82. I mean, that's not just a small number. That number is so absurdly close to 0, it's, for all practical purposes, it is 0. And this is huge. It means if physicists at the Large Hadron Collider ever find any evidence of the Higgs decaying invisibly, the time force hypothesis is instantly wrong. Done. It's a bold, all-or-nothing bet on how reality works. So that's where we are. We're left with this deep, kind of mind-blowing question. Could the universe, with all of its complexity, all of its beauty, all of its particles and forces, really be nothing more than the geometry of a single field? Is this whole rich tapestry of reality woven from just one single elegant thread? The time force hypothesis gives us a radical new vision, and it's a vision that just might, one day, lead us to the holy grail of physics, a true theory of everything.